Hey, welcome. Today, we're going to go on a little journey, a deep dive into the absolutely wild complexity hidden inside some of the simplest words we use every single day. We're going to unpack the incredible mental gymnastics your brain performs just to understand a word like many. So let's start with a little puzzle that shows you just how deep this rabbit hole really goes. All right, so to kick things off, we're going to look at a simple problem. Now, it seems super easy on the surface, but trust me, it reveals something really deep and fascinating about how our minds actually make sense of the world around us.
So let me just ask you this straight up. What does the phrase "a few" actually mean? No, really, think about it for a second. Is it 3? Is it maybe 5? Does it even have a fixed number attached to it at all? This is where it gets crazy, because the exact same phrase, "a few," can mean completely opposite things. If I say, there are a few cookies left, that feels kind of small, right? It's a dwindling number, a warning that they're almost gone. But if I say, here are a few cookies to start, well, that feels totally different. It implies there's plenty more to come. The number of cookies could be identical, but the feeling, the implication, is the polar opposite.
And that right there is the whole point. Words like many, few, or a lot, they don't have some fixed definition in a dictionary that our brain just looks up. Nope. Their meaning is constantly shifting, changing, all based on the context. And our brains have to sort all of that out instantly. That is a massive job.
So that leads us to the next big question in this mystery. What is the engine inside our heads that's handling this incredibly complex task? I mean, how do we manage this constant, on-the-fly calculation without even noticing we're doing it? Well, the first thing to get is that this isn't magic. It's not some effortless reflex. Processing these words involves a very real and pretty significant cognitive effort. It is a demanding mental calculation that your brain is just humming away at in the background all the time.
And the key player, the hero at the heart of this whole process, is something psychologists call working memory. You can think of it as your brain's mental workbench. It's the space where you hold and juggle information to make sense of things, whether you're doing a math problem or just trying to understand a simple sentence.
Honestly, the best way to think about it is like the RAM in your computer. It's this limited resource you have for temporary tasks. And just like some programs on your computer use way more RAM than others, some words place a much heavier load on your working memory.
Okay, so let's take that idea and run with it, because it turns out our language has all different kinds of tools for this job. Not all of these quantity words, or quantifiers, as linguists call them, are created equal. Not by a long shot.
Yeah, researchers pretty much break them down into 3 main buckets. You've got your proportional ones, like most, which force you to compare 2 different sets of things. Then you have the intermediate ones, like a lot of. And then you have the really slippery ones, the vague ones, like many, where the meaning is almost entirely up for grabs depending on the situation.
And here's the kicker. Each of these types puts a different amount of strain, a different cognitive load on your working memory. Figuring out what most means is a totally different kind of mental workout than figuring out many. Your brain literally has to use a different strategy and a different amount of that precious working memory for each one.
Okay, so, quick recap, we've seen the problem. Context is everything. And we've identified the mental tool our brain uses, working memory. But how does the calculation actually happen? What's the formula our brain is running in milliseconds?
Well, in the world of cognitive science, there are 2 big contenders. 2 competing theories. On one hand, you have the prototype theory. This idea suggests we understand many by comparing it to some kind of ideal mental picture, a typical example of what many looks like in our heads. On the other hand, you have computational models, which argue that our brain is actually running these complex, logical, and probability-based calculations.
And when you zoom in on these computational models, it gets really cool. Researchers are using concepts like finite automata, just think of them as tiny, simple logic machines, to map out the step-by-step process of the calculation. They're also using probabilistic models to figure out how our brains weigh the odds of different meanings based on the context and other clues.
And listen, this isn't just some abstract theory scribbled on a whiteboard. Scientists are actually using neuroimaging, tools like fMRI, to watch the brain in action while it does this stuff. They are literally looking for the physical neural basis of our number sense to see how our neurons pull off these incredible calculations.
So, after this whole deep dive, where do we land? What's the big takeaway here? What does all this mean for how we understand language and even how we understand our own minds?
This quote really just nails it.
Processing these little words isn't about looking up a definition. It's this dynamic, live-action mental process. It brings together pure logic, the meaning of the word itself, and our practical, real-world understanding of a situation, and it's all being juggled at once inside our working memory. It's a real performance.
So let's quickly run through what we've unpacked today. We've seen that a simple word, like many, is anything but simple. Its meaning is incredibly complex and totally driven by context. We've learned that just understanding these words is a real mental workout that puts a strain on our working memory. We now know there are different types of these words, and each one has a different cognitive price tag. And finally, we've seen that science is actively battling out with competing models to explain how our brains pull off these amazing, instantaneous calculations.
And that's what I want to leave you with. It's this one final thought to chew on. If a word as common and simple as many involves this much hidden work, this much ambiguity, then just how much of your reality, your assumptions, and your decisions are being shaped every single day by words you've never really truly stopped to define? Makes you think, doesn't it?